first of all, thank you for being patient with me. And I'm realizing, like, the great thing about the summer program is it's helping me figure out what things we might need to touch on. Definitely let me know if something seems like scary, hard, whatever, because I can make it more digestible if it's not digestible as it is. Are these things that you should know? Technically, yes and no. So, yes, because it's helpful. No, because you may not have seen it to this extent before, or seen it so in your face before. So, but today is just logarithms, working with log identities, and working with trig identities. So I'm going to try to work through this. And the way I like to do this first part, it's talking about verifying each identity. It's not actually need to simplify it. It's talking about verifying it. And I actually love doing these. So I hope that you might find a way to do that too. Um, what I'm going to do is to kind of highlight the parts that I'm working on. So this part goes over here. This part goes over here. And this part goes over here. Because I need to change things in order to make this digestible. So you could work with either side, but the goal is to get back to basic identities or to get the same thing on both sides, right? So if I'm working with cotan x, I know this right here. I know that if I simplify that, cotan x is just cotangent x simplifies to cosine x over sine x, right? I also know that the tangent square of x, let's put that in blue, simplifies to, this is sine x over cosine x, or in this case, it's going to be sine squared x over cosine squared x. And this allows me to eliminate some things. It allows me to say that this goes away and that this goes away. And guess what I'm left with? I'm left with sine x over cosine x. So let's look at this other side over here. Okay, that was just the left-hand side. So I'm simplifying, trying to get back to a place using the things that I know. Well, this whole top right here is the tangent. Oh, sorry. No, it's not. The whole top is actually just one. It's just one. It's just one. So everything right here is equivalent to 1. That's an identity. On the bottom, I have cosine x over sine x. That's what the cotan x is equivalent to. If I want to get this out of the denominator, all I need to do is take the reciprocal, right? Take the reciprocal, and this flips over, becomes sine x over cosine x. And then I'm back to where I started. So therefore, it's true. This statement is true. I have the same thing on both sides. I worked it out. Period. I'm done. Look at number next. I have cosecant squared x. So that's going to be 1 over sine squared x right there. And I have secant squared x is going to be 1 over cosine squared x. And I'm going to leave this other side by itself. And I'm just going to simplify right here. So 1, actually, let me take this and pop it up right here. Make this smaller. So I'm going to erase this. Okay. And put a little arrow. All right. So that makes it easier for me to go back through and write stuff. All right. So 1 over sine squared x, right? And then I have, draw my big line, and on the denominator I have cosine squared x. And we want to get this out of the denominator, so we're just going to multiply it up here. And guess what we end up with? Cosine squared x over sine squared x. So that's what we end up with. I'm going to leave it right there for right now. Just for right now, because it's in that way. It's in that term, those terms. So here, over here on the right, this is just 1 over sine squared x minus 1. So I want to combine these denominators. I want to get these on the same level here. This -1 and then this 1. So I'm going to multiply sine squared x. This is algebra. This equals 1 minus sine squared x over sine squared x. So what about this right here? So I can change that to the sum. Remember the sum over here equals 1? This equals sine squared x plus cosine squared x minus sine squared x over sine squared x. This, sorry, didn't mean to do that. So these cancel, and I'm left with cosine squared x, sine squared x. And it's the same thing on the other side. So what I'm going to do is make some easier ones so we can get to this place if we're not there already. All right. Number 2, 3, and 4. These are expansions of logs. So dividing means I'm going to subtract. So this is log 9, a to the 4th, minus log base 9, b to the 5th. And you could expand even further, log base 9, a minus 5 times log base 9, b. Okay, pretty straightforward there. Here I have 2 log base 4 x plus 2 log base 4 y cubed, or 2 log base 4x plus 6 log base 4 y cubed. Okay. Number 3, this is condensing a log, so we can go log base 2 11 cubed plus log base 2 6 to the 18th. So I'm multiplying these two things. So log base 2 11 cubed times 6 to the 18th. Now if I want to get this some form of exponents being the same, I can say log base 2 and do a little bit of a manipulation times 6 to the 6th, and I can cube everything. Over here, log base 4 5 to the 10th divided by log base 4 8 squared. Now if I want to do some manipulation here, I could say 5 to the 5th and it's squared. So what does that look like? So log base 4, 5 to the 5th over 8, and they're both squared. And if your mind's blown, that's fine. That's fine. Number next, we're going to get the limit as x goes to 2 pi over 3. All you do is substitute in here. So it's 2 sine 2 times 2 pi over 3. This equals the limit of, as x goes to 2 pi over 3, of 2 sine 4 pi over 3. And if you look at the unit circle, it's just 2 times negative square root of 3 over 2. These cancel, and this limit equals negative square root of 3. Over here, just substitute 0 in, and I get 4. Okay? And that's all she wrote. So have a good day, guys. I hope this is helpful. We're going to scaffold up and get this down. All right? Have a good one.